Calculus, college calculus today, limits at infinity, horizontal asymptotes. Our problem is evaluated limit of 3x to the second power minus x minus 2 divided by 5x to the second power plus 4x plus 1 when x approaches to infinity. All right. Also, we have to when we do step by step explain what kind of the limits law we are using it. All right. The solution for this problem, as x becomes large, both numerator and denominators also becomes large too. All right. So it isn't obviously what happened to the radio. All right. We need to do some preliminary algebra process, right? We first we have to divide both the numerator and denominator by the highest power of x. Divide the numerator and denominator by highest power of x that occurs in the numerator. In this case, the highest power of x in the denominator, it is x to the second power. Here is x. Let's write here highest power of the denominator of x, highest power of x. Highest power of x is x to the second power, right? This is very important. All right, in this case, or in this form, we will have now in the solution, the first step, we have to write limit here, limit of 3x to the second power minus x minus 2 divided by 5 to the x, 5x to the second power plus 4 plus 1 when x approach to infinity. All right, this is equals, will be equals now, as I told you, we have to divide it by the highest power of x. In this case is x to the second power. So in this way we will have this fraction here, 3x to the second power minus x minus 2 divided by x to the second power, right? In the bottom of the denominator we will have 5x to the second power plus 4x plus 1 divided by also 4x to the second power, right? So when you simplify this fraction, we will have limit of, let's see here. So in the top, we will have 3 minus 1 of x, or 1x, minus 2 divided by x to the second power, right? And the bottom of the denominator, we will have 5 plus 4/5 plus 1x to the second power. All right, when x approach to infinity. All right, so this is our first step. Next step, so let me use a different color here. This will be equals to here limit when x approach to infinity. So limit of we will have here 3 minus 1 or x minus 2 to the divided by x to the second power, right? Asymptote. And the bottom limit of, in this case will be 5 minus 4/5, 4/5 plus 1 x to the second power, right? When x approach to the infinity, all right? This is by limit low number 5, right? Remember, we are applying the limits law in this topic, in this class. So now next step we will have equals here. Let's write it here. Limit of 3 minus limit of 1 divided by x when x approach to the infinity, also is when x approach to the infinity here. Remember minus 2, remember the limit law, okay? Minus 2 will be limit of 1 divided by x to the second power when x approach to the infinity, all right? So that's it, and this is the numerator. In the bottom, the denominator, we will have limit of 5. This case will be 5 plus, when it's x, when approach to the infinity, x plus 4/5. This is not 4/5. Here is going to be 4 limit of 1 over x when x here approach to the infinity. This is plus 5 plus, not together, plus, all right, plus here limit of 1 divided by x to the second power when x approach to the infinity, right? This we apply here by 1 limit law 1, limit law 2, and limit law 3 and 3. All right, limits law, and then this is now you simplify everything here. You simplify here. We will have, in this case will be 3 minus 0 minus 0, 5 minus 0 minus 0, right? You simplify this, easy. This is equals 3/5. 3/5. Decimal, that's 0.6. So that's the answer. This is very important. I will remember you some idea here in this kind of problem. We apply the theorem, also the theorem number 5. Theorem number 5, in this case, I will make the graph. That's very important. But it's important. The answer is done. Our problem is done. I finished. Next step, I will make the graph. I will erase it, my problem. All solution here. Let me erase it. This. But I need to remember you to be able to solve this kind of problems. Remember the theorem number 5. Theorem number 5, which is if R is greater than 0, then this is very important, okay? Then Yeah, greater than 0. Here so b equals a rational number then we have I'm going to make a brief simplify limit 1 divided by x to the r power, this is 0, 1x approach to, in this case, to the infinity. Alright, it's kind of the theorem. This is theorem that very important. Remember, when we working with limits at infinity, the horizontal, and then using the horizontal asymptote. Okay, so keep in mind this kind of theorem, and then you understand why we got it, the answer that I showed you before. Okay, let me erase it here, and then let's do the graph. Let me graph this this problem here. So the graph is simple, very simple. This is y, and let me make the graph is right here, x, and then 1, 0, something like this. And then let me write the asymptote. Asymptote is something, remember 0 is this is asymptote. I mean it's equals here y equals, remember the answer that we got it is y equals 0.6. that we got it in our problem, right? Remember the answer was at 3/5, but the rest is equals 0.0, right? Okay, that's why the asymptote is right there. So now this information here, the horizontal asymptote is this is let me write it here. Yeah, horizontal. Okay, this is horizontal asymptote. So let me make let's make the graph. I'm gonna make the graph something like this. Look at my graph. This is the graph, something like this. This is the graph. The graph show that our problem here. So this is y equals 3x to the second power minus x minus 2 divided by 5x to the second power plus 4 x plus 1. This is our graph. This is the solution for our problem. Very simple. This is the asymptote line. Asymptote line is this one. Is y here. Y. Let me write about red. Y equals. This is the asymptote. So then the graph is running in this way. So some conclusion here, I have some conclusion by similar conclusion, similar here, a similar calculation. Look at this by the graph. Similar calculation shows that you see in the graph. the limit as x approach to the infinity is also 3/5. Alright? This is another conclusion to our problem. So that's it for today for our college calculus. As always, remember if you discover the power of the mathematics, you unleash your infinity potential.